What's 0 minus 11? Negative 11?
Right. So in the next half of this unit, after you take the quiz, then we embark on the second part of this journey. And one of the things that's on the second half is what you're going to learn today. So today is the 20th, and I'm going to show you a different way to graph lines. So we're going to graph today. So we're going to be graphing lines using what we call intercepts. And usually when we talk about the intercept, we've always only talked about the one. We've talked about the y-intercept. So we all know that the y-intercept is the place where a graph crosses the y-axis. But what we're going to do today is we're going to mathematically track down both of the intercepts. And logic, just kind of before I get started. So, I want you to have like a big picture idea of what this lesson is all about. If I asked you to graph me a line and I told you that there was a point here and a point here, would you all be able to pick up a ruler and connect the dots and make a line? You would. And I don't mean to ask you dumb questions like that, but I just want you to really buy in that really honestly, at the end of the day, if I have 2 points, I can make a line, right? So what we're going to do today is we're going to specifically focus on just finding the 2 special points that where the graph or the line crosses through each of the axes. So this one up here, obviously, is called the y-intercept, right? And then this one, for the first time ever, we will start talking about this guy. We generally shy away and hide from him, but now he's going to be helpful today. He's called the
X-axis.
x-intercept.
Oh.
So our mission for today is to find those guys, and it's so pleasantly simple. This process today, when it's meant to work, it works well. It's not always a good idea, but this is one of those sort of niche things in mathematics where if an opportunity presents itself to use today's method, you got to gobble that up. Because as you'll see, there's zero chance that you're not going to understand this today. This is cake math, okay? So that's the goal for the day. We're going to find where it crosses X, we're going to find where it crosses Y, and we're going to connect the dots. Like that's it. And poof, that's a great way. It is very easy. So let's look at it. This is the mathy part of the lesson where I really need your brains turned on. I'm going to make a bunch of points, and I don't want you to write these down because your notes will get cluttered, but I'm going to make a bunch of green dots. And you would agree that all of those green dots are on the y-axis, correct?
Correct.
Okay. So there's always the sarcastic answer, which kudos if you think this, but I'm going to ask you a question. What do those points all have in common? And the sarcastic one is they're all green. Thank you for that. Again, good work if you thought that, because that's what I might have said. The second answer is, well, they're all on the y-axis. So let's get those obvious things out of the way. Having said those, what else do these points all have in common?
They're all
Yeah, we already said you can't answer with they're all on the y-axis, and you can't answer with they're all round and green. Let's think deeper. Josh? What do they all have as a characteristic? Each of them, independent of the others, has something that's the same as everyone else.
They can be graphed.
X, like number and 0.
That's exactly what I was looking for. And I'm never sure at this point in this lesson, how long will this take? Some years it takes 30 seconds and some years it takes quite a few minutes. But you, Nash, saved the day. You'd have to agree with this, that every one of those green points, no matter what else we know about it, every single one of them has a 0 in its X position, correct? If I asked you to get to any one of them and said, give me the coordinates, you'd say 0, 4, 0, 5, 0, -2, 0, -8, 0, -9. So the takeaway, thank you again, Nash, for this, is that every point that is on the y-axis has an X equal to 0. That's going to be what carries the day today, that fact. I don't really want to move on, though, until you buy it. Do we all agree that every one of those green points, if we listed its coordinates, the first number would have to be 0?
Yep.
Good. So now that the secret is out and you know exactly what I'm trying to accomplish, I'm going to make some points on the x-axis, and I'm going to ask you the exact same question. All silly answers aside, those points are all on the x-axis, but what do they all have in common? Their y coordinates are all 0, regardless of which one I pointed to. If I point to this one, or this one, or this one, or this one, we could do this all day. I may not know what their x's are, but I know darn well that every one of them is in the format of something, comma, 0. So we can say that if you're on the y-axis, your x coordinate is 0, but if you're on the x-axis, your y coordinate is 0. Got that? Those pieces of information are what make today's lesson one of the 5 easiest things I will teach you all year. Okay? So let's put this into use. Let's make this practical. Let's make it useful, and let's witness how easy this actually makes graphing a line. And again, it's not always the best idea. I'll show you and explain to you there are situations where it's a bad idea to try to do it this way. But let me give you an example of when it's not, like this. Our current understanding of this process, if I gave you this and said graph it, would be that we would get y by itself, right? We're actually going to take I can't really answer that question. We're not getting anyone by itself as much as what we're going to do is we're going to murder off one to find the other. And then we're going to murder off the other to find the one. Now, you and I just talked a few minutes ago, and we all agreed that to find an x-intercept, what has to be true? What is true about an x-intercept? Thank you, Brandon. And that was the purpose of this portion of the lesson, was to show you that if you're on the x-axis, your y is 0. And we also talked about the fact that if you want to find a y-intercept, what has to be true? Your x has to be 0. It's like a crisscross, and I hope you see why after those first few minutes. So here's what we're going to do. You got to just ask yourself, who do you want to find first, the x-intercept or the y? And I don't care. You guys pick. X it is. I told myself the first one I heard I would do first. So to find an x-intercept, this is what you do. You take this equation and you destroy the y and everything attached to it. And the equation now says 3x equals 12. What is x?
That was easy.
Then the x-intercept is 4. Done. We now know that this graph crosses through the x-axis at the number 4. Now let's start over, go back to the beginning, and let's find a y-intercept. What do we have to do to find a y-intercept?
We have to get rid of all the x.
Get rid of x and everything that x touches. And in this case, that leaves behind a negative sign of 4y equals 12. Divide both sides by negative 4. What's the y-intercept? And just like that, we can make a graph. So I go on my x-axis to 4, my y-axis to negative 3, grab a ruler, make a line, done. Pretty easy?
Yeah.
Let's do it again. And when I'm not up here flapping my gums, you can actually graph a line in 5-10 seconds. But again, so let me explain to you before we do another example. You might already know this, but when is this a bad idea? If it's like 5x minus 9y equals 11. Can you kind of see why this is not the right method to use? If you get rid of the y, for example, what would the equation say? 5x equals 11. And then you're like, oh, I got a non-whole number. That's when this method is kind of dangerous, because now I'm trying to estimate where to put points on my graph, right? So generally, the method we're using today really should be reserved for instances in which you look around and you ask yourself a critical question. Can that number be divided by both of those numbers? And if the answer is yes, then green light that sucker. Get in there and use it, right? Because at the end of the day, that's really what you wind up having to do, is divide the number on the right individually by the numbers on the left. So let's do another one. Let's do x minus 3y equals -6. We can go quicker this time if you want. Let's do x-intercept first. It's a good habit to do x, or to at least to say I'm going to do it the same way every time. If to do x, you destroy y and everything that it's touching, what would the equation say? Yeah, it's literally done. You already know the x-intercept is -6. That's pretty powerful stuff. To find the y-intercept, what do? You destroy the x and everything that it's touching, leaving the equation as -3y equaling to -6. What does y equal? Done. And when you go to graph it, it's a simple matter of saying, okay, I'll go up on my y-axis to 2. I'll go to my x-axis to -1, 2, 3, 4, 5, 6. And I'll put a point over here, grab a ruler, done. Okay. Let's take a look at what this is going to look like quickly on your computer screens. And then after that, we'll be done. You don't need a computer. You can just look up at mine, okay? So on this one, I'll try to zoom in just a little. I think that's probably good enough for you. Feel free to show work or not show work on an assignment like this. You show work at your own discretion. A lot of these you're going to blow through pretty quick. So to find the x-intercept, you basically look at this. I used to work with a lady, a teacher a long time ago. She called this the cover-up method. When she did this on paper, she'd have her students take their fingers and like cover up the one that they're getting rid of. So whatever, however you think that, I don't care. What's the x-intercept going to be? X, that says x minus 4y equals 8. So it's 8. If you destroy the y and everything that it's touching, the equation literally solves itself. It says x equals 8. So what I'm going to do is I'm going to grab this red dot and I'm going to pull it over to 8 like that. Delta does all the heavy lifting for us. It's really nice. And then what's the y-intercept going to be? Correct. If you destroy the x and everything with it, the equation remaining is -4y equals 8. Divide by -4. You can do that in your head. Y equals -2. So I grab the y dot, the blue one, and I pull it down to -2. And then I submit my answer. It's pretty remarkable, isn't it? You will not be graphing lines this way on your first quiz. On the first quiz, I am testing you on your ability to graph using y equals mx plus p. But on the next quiz, after the early December one, then we're going to be having a whole section on the quiz where we get to just do it this way, which is quite nice. Let's find another one. How about this one? What's my x-intercept? We agree on 4. If you get rid of the y, it says 2x equals 8. So you divide 8 by 2 and you get 4. So I grab my red dot and I pull it to x equals 4. What's the y-intercept? 8. And that's how easy graphing lines can be when it's meant to be that easy. How about this one? What's the x-intercept?
2, -2.
Well, it says -2x, but it's going to equal 20 because the y is gone. What's 20 divided by -2? So I'm going to grab my red dot and pull it left to -10. What is my y-intercept going to be?
4y.
5. It's already where it's supposed to be. Submit answer. Done. Do you guys have any questions about this? Okay, let's take a look at this one. So Delta Math threw me a curveball here, but I'm glad that it did. So we're going to have what we call a tweener here. So even though it's not the best method, we're going to follow directions and do it this way. No stress with the x. What is the x-intercept going to be? I want to make sure that no one is lost right now, because sometimes people fade into anonymity and I'm not aware. If we get rid of the y, and then the equation says that, then we divide by -4. Can we all agree that the x-intercept is -7?
Yeah.
Okay, so this one doesn't cause me any stress at all. I'm going to grab the red dot and pull it to -7. But I'm glad you're getting to see this. So for the y-intercept, if I get rid of the x, the equation says 9y equals 28. What happens when you divide 28 by 9? It comes out as a not nice thing, right? So we think of it as y equals, how many times does 9 go into 28? 3, with how many ninths left over? 1. And so this is one where we are just going to cut ourselves a little bit of slack, and we're going to grab the red or the blue dot and we're going to pull it to 3. but we're going to leave it just a hair above like that. So it's not a perfect science here, but I've done this in years past, and with delta, it's pretty generous as far as like I think if I had my dot like up here, would you agree that in principle the computer should mark that wrong?
Yes.
Because 1/9 is pretty close to the bottom. And so if I submit this, I hope it marks it wrong. Good. So it's going to judge you on like just common sense. Are you close to where you should be? For 1/9, I should have pulled it down. It's going to need it to be above 3, but just by a little bit, right? So that's what we're going to practice today. Do you guys have any questions about that? This assignment today is on Delta Math. You should be able to blow through it in about 10 minutes flat. Good, good. All right.